So when we solve a right triangle, so when you see the directions in the book and they say to solve a right triangle, that means that you find 6 things. All right? The 6 things that you need to find when you solve a right triangle is you need to find all 3 sides, and then you need to find all 3 angles. Okay? That's what you have to do. Find all 3 sides and all 3 angles. That's what it means to solve a right triangle. So some of the directions tonight, they say, solve the right triangle ABC for all the unknown parts. Well, that's what that means. So let's do an example of that. And let me give you a triangle here. And let's say that this is some angle theta, and this is going to be some angle alpha, and this is a right triangle. And I know that this is like 11, and then this is 8.5 for this right now. Okay? And I'm interested in solving for this triangle here. Okay, so I need to get all 3 sides, all 3 angles. All right? Well, the hypotenuse is pretty easy to get. Okay, so what's the first thing that we're missing here of all the sides? Yeah, we're missing the hypotenuse, right? We don't have the hypotenuse. So can we easily get it? Of course we can. We just go 8.5 squared plus 11 squared is equal to the hypotenuse squared. So go ahead and now calculate that. Tell me what you get. So we have independently verified that the hypotenuse is indeed about 13.9 units long. Okay, so now we know that this is 13.9. Okay, so far. So now we have all 3 sides. What about the angles? Well, I know one of them is 90 degrees. So let's focus on theta for a second, okay? If I take the tangent of theta, then I know that its ratio has to be opposite over adjacent. Very good. So that has to be 11 over 8.5. Okay? Now I chose to use tangent because 11 and 8.5 were given to me, right? Let's just say, for an example, I accidentally messed up and the hypotenuse was not 13.9 and I decided to use it again. Well, then I'd carry that mistake over again. So I'm just being careful and saying, okay, well, I'm going to use the ones that they gave me. Now, when you see tangent of alpha or theta equals 11 over 8.5, what does that actually mean?
That's the angle.
Yeah, it means that the angle whose ratio of 11 to 8.5 is defined by tangent. Okay? So if I'm interested in just the angle, how do I get it?
You have to put it in your calculator.
Yeah, okay. So I'm interested in the angle who has a tangent of 11 to 8.5. So what I have to do is I have to introduce something called, okay, the inverse tangent. So the angle that I want, that's the thing, is equal to the inverse tangent of 11 to 8.5, right? So when you see that, your brain has to think, okay, this is the angle whose tangent is in ratio of 11 to 8.5 for opposite to adjacent. Now that little -1 does not mean 1 over tangent. It doesn't mean that, and it doesn't mean cotangent. Okay, it means the angle whose tangent is 11 over 8.5. That will give you this angle right down here. So how do we get that? We can use our calculator for this. So take your calculators out for me. Make sure you're in degree mode to get this answer. All right? So you can check to see what mode you're in by checking sine 90. Sine 90 should always be a value of 1 if we are in degree mode. In my case, it is. And of course, it just says degree right there. So here we go. I'm interested in the angle. So I want to do the inverse tangent is the button that's in, was that blue? Blue right above the tangent button. So if I go second tangent, notice in the calculator I now have inverse tangent. Okay? And I'm interested in the angle whose tangent is 11 to 8.5. And calculator gives me 52.3. I'm going to use the same number of decimals that's been given to me in the problem, so I'm going to say 52.3. You guys okay with that part? All right, good. So therefore, theta has got to be 52.3 degrees, and that's how I would get it, right? And I put it right there. Now, how do I get alpha then? Yeah, Nick, do you know?
90 minus 22.3.
There you go. Just go 90 minus, right, 52, 52.3. And what am I getting here? I'm getting 37.7. All right. So that's 37.7. Of course, I could also just do the same thing on the other side, but this is a little bit easier step. Okay, so do I know all three sides, ladies and gentlemen? Yes. Do I know all three angles, ladies and gentlemen? Yes. Then that means I have officially solved the right triangle. This is a building, my friend. This is a building with windows. There it is. Okay.
Wait, it's not like a halfway window.
Oh, and then you're standing at the top and you can see down. You can see right angle.
Well, okay, kind of right. This is a classic
Oh, so
application.
This is
Angle of elevation and depression. Oh, you guys know. No, it's not that. Okay, so here you go. You are standing over here, and you're having a wonderful day, and you have walked back exactly about 92 feet from the edge of this little building, right? And there's a little awning here, and you're having a little cafe, and it's all good, and everything's nice. And you're taking a walk, and you look back, and you go, I wonder how high. What's the height of that building? I wonder how tall it is. All right, so it's classic, right? So what you do is you take an angle of elevation from your position
How do you know how far that is?
to the top of the building. Your iPhone tells you because you have an inclinometer. Did you guys know that, by the way?
We have an what?
We just had a class moment. I wish you guys could have seen that. We figured out that through our iPhone that this angle was, that's a big marker. This angle was 41 degrees.
How do you do that without an iPhone?
There are instruments. They're called inclinometers.
Oh, how about if you tap it?
No, you don't. No, you don't. Okay. Okay, we're interested in figuring out the height of the building. Our iPhone, using our inclinometer, told us that the measure was 41 degrees, which is pretty sweet. So look, I have this information. This is the opposite side, and this is the adjacent side. So I'm going to use not cosine, I'm going to use tangent, okay?
Oh wait, I thought
Because
we
the
were doing
tangent-
Pythagorean.
The tangent is the definition of the opposite side, right? So the tangent of 41 degrees is equal to h divided by 92 feet. So therefore, if I multiply both sides by 92, right, I would get h is equal to 92 multiplied by the tangent of 41 degrees. Now I want everyone to realize that the tangent of 41 degrees is nothing more than a number. It's a decimal, right? So we take that information and we plug it straight into the calculator. So we go 92 times the tangent of 41 degrees. Look how I've plugged it in. Pretty straightforward. Nothing to worry about there.
79.
Push enter. We're getting 79.8. All right. Wait, what is it?
It's like about 8.
It's 80
No, it's
degrees.
80.0.
Oh, yeah, that's by 80 degrees. Yeah, think about it. Round to 80.0. So h is approximately 80 feet. So check this out. There's another classic problem in trigonometry. There's this thing called the sun that's up in the sky, right? That's amazing, right?
There's a shadow.
And then the sun hits the flagpole and it makes a shadow on the ground, right? And the shadow looks something like this, right? Artistic interpretation. That's pretty darn good. I think so. Okay, we'll cover that in as well. Now, so here's the deal. It is a known fact that this particular flagpole is 30 feet in height because we measured it in a previous problem. Okay?
The shadow is straight. Is
The angle of the sun is shining down right now and it makes a shadow to the flagpole. And we can measure the length of the shadow to be about 32 feet. Okay? So the question that I have for you is, what is the angle of elevation to the sun in the sky? So I'm looking for, basically if I were to draw this triangle, I'm looking for this angle here. This is my angle theta of elevation. All right, that's what I'm looking for. That's what we're trying to figure out. We're going to use trig to do it. Again, I'm going to use the tangent feature. Okay, so I know that the tangent of the angle I'm looking for has to be in ratio of what to what, everybody?
32.
Yeah, 30 to 32. Very good. So therefore, theta has to be the inverse tangent of 30 to 32. So theta is going to be whatever that happens to be. The calculator is a good place to start. So I want the inverse tangent of 30
43.2.
to 32.
Insignificant.
Get an answer. I'm going to go to 43.2 degrees. So 43.2 degrees angle of elevation to the sun in the sky.